All right, good morning. How is everyone today? Good, we got people awake, awesome. All right, so somebody asked for optional features or additional features for homework 7. What's the difference between adding a time to an appointment and adding an end time as well as a start time? You can take those as two separate features. Adding a time means that, you say you have to go to the hairdresser not just, next Tuesday, but next Tuesday at 2 o'clock. So you're having a date and a time for each appointment. That does not mean that you have to say, when the appointment ends. It can just be this appointment is at this date, this time. If you also add an end time to it, that'll count as a second feature. Okay, it's a really simple add-on. Just have a date, start time, and an end time. But that will complicate things if you're looking for conflicts, for example, and so on. So, but yeah, so that's what I meant by those two features in two separate lines on the assignment. All right. So this is your last chance for homework 7 questions. I'm not going to answer email questions after 12 o'clock today until tomorrow. So any questions, any problems, concerns, confusions, this is the time to get them out there. How would you like us to present our program? Yeah, so we'll probably start presentations tomorrow. I think I'm going to talk about your next assignment tomorrow, and then we'll start group presentations. So basically, whoever's ready to present, you'll just go ahead and share your screen or screens. If there's more than one person in a group and you both want to do presentations, you can take turns showing and talking or whatever. You can figure that out before yourselves. Like I said, it's probably worth spending a little bit of time just rehearsing what you're going to do. And then basically, ideally have some appointments in your appointment book. Show us, looking at the appointments, searching for appointments, adding an appointment, whatever features you've decided to put in, demonstrate those to us, and just basically show the whole class, what your program does. Show the required behaviors, and then show the additional features that you added in. That will be the bulk of your grade. And then, if there's something in your code that you wanna tell us about, right? You can do that. Otherwise, just give us a quick run through of your code. Just show it to the class, right? And if there's something you want to point out in there, something clever that you figured out, right? You can do that. Shooting for ideally 5 minutes per presentation, because we have 50 some people and not a whole lot of groups. So that's the basic presentation guidelines. Submission should be on GitLab. There's detailed instructions on the assignment. Follow those. But the same drill as usual. And it says in there only one person per group should submit. If there's multiple submissions, I will grade the first one I find for anybody in the group. And if that submission doesn't work and you come back and tell me, oh, no, you're supposed to grade such and such, I'm still going to grade the first one I find. Right? So you can all put your stuff in Git, but make sure only one of you adds me as a reporter. Okay? Alright, if your group is split between A and B, still only one person per group needs to present. So the presentation might occur in section A, it might occur in section B. If more than one person really wants to present, then you can do the presentation twice, and some people will do it in A, some people will do it in B. But it's not required. I only need to see the project presented once. Doesn't matter where that happens. Do we need to get rid of any extra files in our Git repos? Yeah, it's on the assignment under grading criteria. You have to have a, well, let's just take a look, because there's what I intend to do and there's what actually happens. I did not mention in the assignment that you need a clean Git repo, so that's let me make sure. Yeah, you can have extra stuff in your repository. I didn't actually say that it needed to be just a bash file, right? So yeah, you do not have to get rid of extra files in your Git repos. Yeah, you're good. All right, other questions? When I say first submission on Git, you mean as far as if there's multiple submissions? I mean, I'm gonna run a script tomorrow morning at 8 that will pull down all the homework 7 repositories that have me marked as a reporter. And then when I start grading, I'm just gonna go through those in order. And if there's 2 people in a group that have both submitted, whichever one I encounter first when I'm grading, that's the one I'll grade, right? So just make sure that only one of you has me added as a reporter, or make sure that all of you have exactly the same code uploaded, right? It's not a big deal. It's not something I'm doing to try to trip people up. Just you know, if there's 15 groups, ideally I would like to grade 15 repositories, okay? And I don't want to grade, 3 people's repositories that don't work and then have someone say, oh no, you should have graded this other one, right? So just clean up your status. Ideally, like I say, just don't add me as a reporter unless your repository is the one that you want graded for your group, and then I'll never see the other ones. And yeah, I always pull down the latest thing that's been pushed to Git, so I'll always see your final submission. All right, good. More questions? I know there's more questions. So I posted a video yesterday that I think most people noticed. I sent out an announcement on it. I hope everybody is getting alerts for announcements. So I posted a video with several sort of short and quick tips, tricks, ideas, hints, things related to Bash that will possibly be helpful for Homework 7. So reading a file from Bash, using sed to replace characters in a line, capturing output from dialogue, building up a string inside a loop, stuff like that. So I know that's helped some people, but if you're really stuck, right, go ahead and look at that. There's should be enough in there to do most of the things that you need to do to finish up Homework 7. All right, so we'll start doing presentations tomorrow, and everybody should be ready to present. Okay, we probably won't get through everything in one day, but we may get through it in 2 days. But here's the deal: you've got to present to get grades. Somebody in your group has to present to get a grade on this assignment. So we'll start tomorrow, right? And it's going to be volunteer. So I'll say who wants to present. You can go ahead and present. If we get to a point where I say who wants to present and nobody in the class wants to present, the assignment is over at that point. And if you haven't presented by then, it's a 0. Okay? So make sure you're in class. Make sure you're in class the whole time until presentations are done, right? At least. It's not an option, you know, if Monday we do presentations, we get halfway through, I say, anybody else want to present? Nobody says they want to present. The assignment's done. Don't come back Tuesday and say, oh, I didn't present yet. Can I present today? Okay? I wanted to get these presentations done in one block, and then we're going to be done with it. So absolutely make sure that you're coming to class, you're tuned in, you're paying attention, right, and you're ready to present. And just present as soon as possible, right? That's your best bet. All right. Somebody said they enjoyed playing around with Homework 7. That's awesome. Bash can be a lot of fun to play with, right? It's more instant gratification than, say, C, for example, and way more than assembly language. Yeah, I hope people are having fun with this. I also like to assume that we can add as many features as we want, but we just need to have a minimum of 3. Absolutely. If you want to go above and beyond, that is awesome. If you want to add, you know, whatever embellishments you like, that's great. As long as you got, you know, the required features plus 3 extra, at least, you're good. Yeah, it is a nice change of pace, and I think I've decided that your final programming assignment is also going to be a Bash program. I wrote it up last night as a C program. It's 6 pages long, it had lots of details, and I think it would be a really good C program to have people work on, but we're going to do nothing but C in 222 in winter. So I'm going to go with one more Bash program because I really want people to get as comfortable with Bash as possible in this course, because I really think it'll help you down the road with not just your other courses here, but, you know, as you go on to university, being able to set things up in Bash, make things customized, will be a big help. So final programming assignment is going to be another Bash program, and it'll be a fun one. The other thing I just want to mention about Bash is, remember, you know, Bash is basically doing things that you do from the command line. So for example, you're trying to you know, read a line from a file and get rid of all the spaces, and, you know, change them all into one space, for example, so that if there's, you know, 5 spaces between a word, you want it to be just a single space. And you're doing this with the output of a dialogue, and you're going to put that into a file and do something else, and your code's not working, right? So what can we do? So yeah, let me turn on my screen share. Thanks for reminding me. Well, I've just been talking all this time with nothing to see. All right, there we go. So yeah, say you want to, you know, take a line from a file and compact all the multiple spaces into a single space, and you're going to use sed for that, and you've got this in the middle of, you know, 50 lines of Bash, and it's not working, right? You can come out of your script, you can forget about your program, you can just come to the command line and try things, right? So you know, the way you would do this would be sed substitute space asterisk slash slash, right? And that doesn't seem to work, right? So then you think, okay, well, maybe I need to do this globally. So, right? So you try that, and that seems to work. You know, you can mess around with this stuff as little pieces, right? You can write while loops. On the command line, right? So you want to know if this will do an infinite loop, you can just write this up on the command line. You don't have to put it in the script. You don't have to put /bin // you don't have to put in change mod and all that kind of stuff. I'm just writing, you know, straight on the command line, and yeah, there's my infinite loop. That works. So yeah, playing with awk or sed or syntax, or doing variable substitutions, or especially, you know, dialogue commands. Don't be afraid to just work, you know, directly from the command line. right? How do we know if grep finds something? Well, let's just run a grep on a file and take a look at $question mark. Hey, it's a 1. 1 must mean that it doesn't find what it's looking for. Right? If I search for echo and then I look at $question mark, that's a 0. Hey. So right there is a nice little validation that $question mark shows you the result of running grep. Right? So let's say you want to know how many lines you matched with grep. Well, and also, you know, if you're just looking to see if something's in a file, it produces all of this output, right? Well, one of the things that I think I mentioned in this video is you can take the output of grep and you can send it to dev null, and then you never see it, but this variable still gets set. So that can be useful. Or if you want to know how many times something occurs in your file, right, you can do your grep and you can pipe it into word count. And I can see, oh, that word echo occurred 5 times in my file. And if I just want the 5, I can pipe that into awk, and I can say print string 1. And there's my 5. And if I want to know, can I capture that into a file? Well, I can do the following. Just say lines equals and put that whole thing in back quotes. Back quotes. Right? So I've cobbled together a whole section of code now, right? A whole bunch of different things I'm doing. And now, you know, you can go back through your history and see what you've done, and then you can copy and paste into your script and so on and so forth. Right, or you could do WC-L to get the words, the lines. So yeah, it sounds like some people have been doing these kinds of things, so awesome. All right, good. More questions? All right. Well, let's play with sed. Let's see. Found this command as an example of something you could do with awk that I thought was pretty neat. Shows how often you use commands. Ah, nice, nice. So let's put this up here. Right. So this is classic, right? Bash manipulation, right? History shows me a list of 2,000 commands that I've executed most recently. When you put that into awk and you print $2, well, $1 will be the command number, right, in the numbered list. $2 will be the first piece of the command, which is the name of the program that I'm running, right? And so if you do that, you get this big long list of commands. If you want to know how many times these things occur, you can use unique-c, and unique-c shows you how many times something occurs in succession in a file. So if you sort a file first, unique-c shows you how many times a particular line occurs. And the output of unique-c is a count followed by the thing itself, right? So that's what that is. And then if you do a sort-n, that will sort it numerically. And if you do an rn, that should sort it reverse numerically. And then if you pipe that into head, it'll show you the first 5 or 10 lines of that output. Right? And this is just the way you start to think when you work in Bash enough, right? This is how you kind of see the world, just blocks that you can put together to do whatever. And again, you know, when you're trying to do something like this, you can build it up. Okay, there's my list of commands. If I unique it, you know, most of these are 1 unless I happen to do the same command multiple times in a row, like I did with history. So sort it first. Right, and now, you know, my while command appears all next to each other, my VIs appear next to each other, and so on. If you unique, you'll just get a list of commands. And so I can see how many unique commands I've done in the past, you know, however many weeks, and it's 106. That's more than I would have thought, and so on. Alright, cool, nice example. Alright, so sed. So, 2 ways to invoke sed, basically. Sed with a program and a file, or sed with a program file, right? Right, so this is the file you want to process. This is either a program specified as the second argument to the command, or it's a -f followed by a file containing a more complex program. And the normal behavior of sed is to copy input from this file and send it to standard out. If you do a -n, that says don't echo the input. So output will only appear if you actually ask it to do an output of a line. And if you don't specify a file, it'll just read from standard in. And so if you want to use set to process the output of a command, you can run a command, pipe the output into sed, and give it a program or a program name, and it will process the output of that command. Alright, so our programs usually look like, you know, an optional address followed by an optional second address, and then some sort of instruction. So when you look at documentation for Linux, right, usually optional things are put inside brackets. So each line of my program could be just an instruction, or it could be an address followed by an instruction, and so on. And an address could be a line number. It could be, of course, a $sign for the last line. Or it could be a regular expression. So it could be a regular expression in between 2 /. And the idea is, each time that a line is read from the input, the whole program is executed against that line. And each line of your program, it checks to see if you match this address specification, meaning that the line was, you know, either this line number or between these line numbers, or the line contains something that matches this regex. And if it does, then it executes this instruction. And that's the basic life cycle of a sed program, right? So reads lines of input, goes through your program, does some processing if the line matches this specification. All right. So if we have sample file here, a program that has no specification, right? This says read from standard in. There's not going to be any instructions in this program that specify any, you know, pattern, so nothing in this file is going to match, no instructions are going to be executed, but it's still going to do this default behavior of copying standard in to standard out. So this is going to give me an echo of my input file. If I do a -n, then this doesn't show anything. If I make a program like P that says print, And since I didn't specify an address, it prints every single line. If I say 2, 6, print, it will print the lines between lines 2 and 6. So we got from banana down to orange juice. Right, there's line 2, 3, 4, 5, 6. So it printed out those lines. Right? So a really easy way to pull out, a piece of a file. If we want to print everything from line 10 to the end of the file, we can say 10, $, and it prints out the foods starting with spam, right, which is sitting here at line 10. If we want the last line of the file, we could just say $. If we can't do that. Forget that. Yeah, hot dogs are unknown. All right, and then we played with this. If we just want to print out red foods, we can search for a line that contains the string red, and there's our red food. Oh, we need a dash in. And so apples and spaghetti are red. Spaghetti's not really red. Spaghetti sauce is red. Yeah, that's where my brain was. All right, so let's look at some of the instructions we can use. So instructions, P means print. Q means quit. Means when we get to something that matches this pattern, we're done. Exit the whole program. Food dye can make spaghetti red. True, and also if you get like beet spaghetti, right, which is colored with beets, like vegetable spirals and stuff. I'm really hungry. I haven't had breakfast yet. All right, so Q will quit processing when we get to that. All right, we can do an A, which says append, an I, which means insert. And usually, right, kind of standard, insert means insert before the current position, append means append after the current position. So I and A and VI, for example, work like that. And VI is a derivative of ED. This is the stream version of ED, so there's harmony in all of this stuff. C is for change, so we can do some replacements. S is for substitute, right? So the usual searches we've been doing in VI. And there's some other things we can do as well. So let's play with some sample SED programs. Let me see what we got here. All right, so here's a program. It has one line with a pattern, and the pattern is 2, so I'm looking to match line 2 of my input. And my instruction is A followed by some text. Okay, and my text is this was added after line 2. So, and then the second line of my SED program is just a P for print. So this is going to take my input file, it's going to read each line, and if it matches line 2, if it's the second line of the file, it's going to append this to the output. And then regardless, it's going to print a copy of the current input line. All right, so if I run this, SED will do the file P2, I'll do a -N to suppress the usual echo operation, and I'll run this on foods, and here's our output, apple, banana, and then this was added after line 2. So we pushed something in, in the middle of the file. Alright, here's a different version. We have 3 lines in this SED program. The first one says if we're on line 2, append this after the line. The second line says if we're on line 2, insert this before the line. And then regardless of what line you're on, go ahead and print the line. So if we run this, right? So first line of the file, second line of the file, and we put something before and we put something after. Right? So these are edits, these are changes to files that you might want to make, and you're making them not by going into an editor, but by basically specifying instructions, and then just running your file through SED with that instruction list given as a program. Alright, so we can do this with patterns instead of line numbers. So if there's a cookie on the line, we're going to insert a message before, and we're going to append a message after. So we're talking about SED. Alright, so now all my cookies are sandwiched by little messages. Alright, usual practice in Linux, you can put a backslash as the last thing on a line and it becomes a continuation mark. And it says that this one line in my program actually continues down here and down here. So now my program, the first line says if you find a cookie on the current line, insert the following before it. And it says insert a new line followed by here comes a cookie. And then if you find a cookie, append that was a cookie afterwards followed by a new line, and then go ahead and print. And so if we do that, we've got our input file with spaces added around our cookie sandwiches. Alright, substitutions, we've been doing these in VI, just substitute /old/new, and this is where you can use regular expressions and registers to replace things that match and so on and so forth. So just doing some straight substitutions here. But not matching anything. Oh, but I'm not printing anything, right? So if I put a P after this, right, now I've got my types of food changed to uppercase. If I don't have a print in here, I can get rid of this -n, and this will say, you know, copy my input to my output automatically. Right, but I'm doing these substitutions in place. And so the thing I posted in the video yesterday and we've talked about before was, for example, if you just want to replace, say, spaces with pipes, right, we can do this. Well, why does this work? This is really a very short one-line SED program, which says, you know, perform this replacement on every line. And so this changes my file from space separated to pipe separated. If I did this, it would make that substitution, but only on lines 2, 3, and 4. So right here. Alright, and so this is why, you know, we can use this to replace spaces with commas or whatever. And this is probably the most common form of SED that I use. This is really the only form of SED I use in regular practice. I use awk a lot in daily life, but sed mostly it's just do a quick edit on every line of a file, and that works. How do you make it replace all spaces with what? What should we replace them with? And what do we mean by all spaces? So if I did this, substitute slash space slash question mark, right? That replaces the first space. If I want to do all of them on a line, put slash G at the end. That makes it global across the whole line. Is that what you were looking for? Cool. I have no idea what I meant for this to do. Delete everything before a certain color on a line. So you want to go through and delete everything until you find red, and then you want to keep everything else in the file at that point? Is that the idea? I'm sure the answer is yes, but do I know how to do that? I'm thinking no. So you can go through and you can look for red, and so here's what would occur to me. Shouldn't have used red because it's the first thing. So let's look for the first. Clear object. Okay, so let's search for clear. All right, and so that tells me that 1, 2, 3, 4, 5, 6. First 6 lines of the file don't contain clear, or the first 5 lines until the 6th. So I would do that, and I would pipe it into word count -L. And I would say, you know, skip equals that. And then I would do that. And so that tells me I have to skip the first 6 lines of the file. And then I would take that and I would throw that into maybe the tail command. So head and tail are good commands to look at, and you can normally use them to look at the first n lines or the last n lines of a file, but I think we can cobble this into something that would skip the first n lines. So I'll put the last n lines, and so I'll put starting. Okay, so tail -n plus num starts outputting with line num. So alright, so that would start looking at with clear. So I would do this. Search for clear, quit your search once you get to the first occurrence of clear, see how many rows you put out, don't do this subtraction from 1, just take that skip and use a plus sign in front of that with tail dash n, and it'll start showing your file from that point down. Right? Now that's maybe a goofy way to do it, and someone who knew SED would say, oh no, you just use the skip until read option, right? You're just putting things together, right? So yeah, so something like that. Nice question. So what is this going to do? Like I said, regular expressions are easier to write than they are to read. And look for a backslash followed by letters followed by spaces and get rid of them. Yeah, so there's another way to do it with SED that somebody just suggested. So someone just suggested this, and I think something like that would work. So yeah, do your skip, just skip -1. I'm not sure if you can put this right inside. Inside SED, yeah, that might work. Maybe $paren. So now you make a SED command that says from 1 through line 6, delete. And then if you run that, that should give you your output also. Let's see, how does the pipe work? Does it put your output from the first command as the input in the second command? Exactly. So this is executing the SED command, and all the output that gets produced goes into the input of the word count command. Right, for example. Or, you know, take your history, take the output from that, run that into awk, take the output from arc, put it into sort, and so on. Yeah, you can make, you know, pretty close to one-line bash scripts for a lot of stuff. And you can split it up by, you know, using temporary files or variables or something, but a lot of times we just chain all this stuff together, and you get a big, long script out of it. And, you know, when you do something like this, you have, you know, multiple commands being fired. There's a history command running, there's an awk, there's a sort, there's a unique, there's another sort, there's a head. You'd have 6 commands running in parallel, each one churning away on its input, generating output which goes into the input of the next. It's arguably inefficient, but who cares, right? Especially if it's interactive stuff. You know, might take 1,000,000 cycles to do something, we don't care, right? That's the 1,000th of a second. Cool. All right. Let's just run this program and see. What this does. Yeah, it doesn't do anything. SED. I don't know what I intended for that program to do. So we won't worry about that. But let's go on to playing around with spaces. So here's a really strange looking SED program, right? It has no pattern to match, but it just says append, and then I, you know, have my continuation, I have another line, I have another line. What's this going to do? It's going to add blank lines after each line of my input file. So if I do awk SED fp7 dash foods, right? This triple space is my input. Alright, so here if I find the word cat in my input, I'm going to insert the word changed in the beginning, and then I'm going to replace cat with dog. So this will make changes to my file, but it will also put a marker in front of each changed line telling me that line has been changed. So you can do all kinds of things here, right? So mostly, you know, that, or you know, with a global after the end, is probably what we're going to do most with SED. Just editing lines one by one, doing the same substitution on each one. Remembering that we can do regular expressions, right? So if I wanted to switch around the order of these things, right, what could I do? I could say match the beginning of a line, put a bunch of stuff followed by a space, bunch of stuff followed by a space, bunch of stuff followed by a space, bunch of stuff followed by the end of the line, and now I've moved the contents of each field into a register 1, 2, 3, and 4. And so if I just wanted to print out, you know, the color followed by the name of the food, I could replace this with $3, $1. And if I mess up, right, this is a sed command, so I can you know, go back and edit this instead of if I'm in VI. So if I do this, right, I get, you know, yellow bananas and brown kiwis and clear water and that kind of stuff. Right? So this is another good way to play with regex. But if you want to do manipulations like this, right, there's a better tool for this, which is awk. And in awk, this would just look like that. Right, and that's a little better behaved than a little easier to read than this stuff. Alright, so sed mainly for making edits line by line, awk really for rearranging fields. So we want to dig into awk. Yeah, some dark Oreos with a dark burger and dark Coke would be good. Alright, so plan for tomorrow. I want to talk about the next homework assignment, okay, programming assignment 5, and then we'll start doing presentations. Okay, presentations will probably run through Monday, and then we'll go ahead, we'll talk about awk in detail, we'll talk about a few more commands that we should know about, TR for transliteration of characters, and then we're going to go back in, we're going to pick up all the other stuff that we're missing. So we're going to talk about files, we're going to talk about links, symbolic links and hard links, and we'll talk about associative arrays and plain old arrays in Bash. We'll probably do that on Monday before presentations continue, to get you what you need to do your last homework assignment. And we'll just wrap up some other stuff in Bash, and then we'll go back to talking about C, and we'll probably start looking at some system level stuff, so some stuff related to processes and such. Next week's a full week, the following week we only have 2 days, and then it's our last week of the quarter, so we're getting there. Alright, have a good afternoon. I will see you next time.